Okay, hey folks, very quick video on calculating entropy changes accompanying chemical processes. This will be very similar to how we do this to calculate enthalpy amongst chemical changes. So you can see we've got our standard reaction entropy, and that's given as the sum of the entropy of the products minus the sum of the entropy of the reactants. What I wanted to note here, which is different than delta H, recall in the standard enthalpy of formation, it is 0 for all elements in their standard state. However, as we've just discussed, an entropy of 0 means something entirely different. However, by convention, and so that means this is not necessarily real, it's just a standard convention we take, the entropy of an H plus ion in an aqueous solution is given as 0 as a reference point. So the actual third law values, actual third law SM molar entropy of H plus is agreed upon to be around negative 21 joules per K per mole, but that's very difficult to actually measure. And the idea of this actually being negative is that it suggests the presence of H plus in solution makes the solution more ordered by a decrease in entropy. All the same, with this 0 being our reference point, we can relate that to the presence of other ions in solution. So for example, entropy relative to this H plus of Cl minus aqueous is positive 57 joules per K per mole. And so that's because the chloride induces less local structure in the surrounding molecules, which makes it slightly more chaotic or gives it slightly more microstates. On the other hand, the entropy of magnesium 2 plus relative to that 0 H plus, let's see, where did that value go, is negative 138 joules per K per mole, indicating that the presence of magnesium ions induces a lot of order in the solution. Okay. So the important thing to recognize, however, is if we want to calculate standard entropy of a reaction, we can use this formula just like we did before. And we want to note when we're using these standard molar entropies, those are coming from our third law entropies that we get here. And you can see, for example, these things in their standard states, like carbon, for example, is not 0, right? Or if we look at helium or hydrogen, these values are not 0. So that H plus ion being 0, that's a good reference point for how we can think about the way other ions induce order or disorder in an aqueous solution, just as one example. Okay, that's all that I wanted to say about chemical processes. As always, we'll do some examples of this in our live lecture. I'll see you then.